Okay.
Okay? I already miss you already, you know. Okay?
Okay.
So that is our point y. So in order to find our point y, right, I'm going to draw a point y, right? This distance from here to here, this distance from here to here, right, is also equal to what? Is equal to 6, right? Because you count, if you were to count the number of boxes, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Same distance. If you can see the box, okay, the square boxes, okay. So now we know how to find stress Y2. Stress Y2 is equal to 8, where the stress average is minus by 6 because it's going to the left hand side. So this is equal to 2 KSI. Okay, that's equal to 2 KSI. So now, is this answer valid? Okay, is this answer correct? So we know, right, that the maximum shear stress is 10. I'm going to draw a circle now. Right. Then I'm going to move it to here so that it can touch point X and point Y. Okay. So that is one circle. So to check whether this answer is right or wrong, right, you have to know, you have to draw 3D-Mohr circle. So this is for your XY plane. Okay. We are also aware that Z, point Z on the element, this point Z over here, on the element has 0 normal stress and 0 shearing stress. So we are very sure now that point Z is over there at your 0 point. Okay, that is your point Z. Then you can draw 2 more circles. So one circle is over here. If I think I have to move this a bit. Okay. So one circle is over here. This circle corresponds to your YZ plane. Okay. And then we have to construct another circle. This circle over here corresponds to your XZ plane. Okay. So now after constructing the 3 circles, we realize that the answer is valid. Okay. So when it is 2 KSI, right, this answer is valid because what we just found, right, over here, right, is that your stress max, your stress max is equal to 18 KSI, and your stress mean is equal to minus 2 KSI. Okay. So this answer is valid. Okay. So the answer is valid because the maximum stress and the minimum stress are within the what? Are within the box. Right? They are within the box. That's why it's valid. And the shear stress are within the box. You have a question? Later. Okay. I'm going to explain why the 20. Okay. Okay. So you'll get that now, yes? Okay, now, why is it 20? Okay, now, point Z over here has 0 normal stress and 0 shearing stress, right? So now I'm going to explain why 20 KSI and minus 20 KSI are your stress max and stress mean, right? Why is that? Okay. This is because point Z, stress Z has 0 KSI. So this is like an anchor. Okay. That point will always be there. Are we clear? That point, regardless of any loading situation, Z will always be equal to what? 0. Okay. So this point over here, that I'm going to highlight in yellow, is always equal to what? 0. Okay. Regardless of you have positive shear, negative shear, X change to whatever magnitude, Y change to whatever magnitude, Z will always be there. Right? So if that's the case, right, stress max and stress mean is equal to 0 plus or minus 2 of tau max. Because this is the what? Radius. Yes or no? Tau max is the radius, right? So relative to stress Z, right, you will have positive 20 and minus 20 KSI. Right? Does that make sense to you? Don't change the question. Okay? This is unique for this case. Okay? Later on, okay, let me ask you. When we do compound loading, if you look at your homework, did you ever see stress Z has a value? Yeah, none. The only way that stress Z has a value is when the structure is submerged in water. Okay? That's the only time. So for this question, okay, most of the time or most of the structure that we design, right, stress Z is equal to 0. Okay? Right. Can you go over it one more time? What is it one more time? Okay, why is it 20? Yeah, Johannes, am I right? Okay, this is because, okay, stress Z is always equal to 0. So this is stress Z is equal to 0. We know that the radius of the circle, the radius of circle is equal to 10 KSI. Because this is our what? Our tau max, right? So if that's a radius, our diameter, this is very bad. If that is radius, our diameter of the circle, right? Diameter of circle is equal to 20, right? It can go plus or minus 20 KSI. Agreed? Johannes, you agree? So that is why our tau max and tau mean is 20. That's it. Okay. Okay. So this is one possible answer. And if you look at the solution manual, okay, this answer is valid. Okay. But we did not need to go to the level of math. We also calculate our what? Stress A, which is our stress max, is 18. And this is equal to what? Minus 2. We just construct the what? We just construct the circle. Okay. We no need to do those equations. Okay. So there are two other possibilities. Okay. So we have done, so there are, in fact, we can construct 4 possibilities. We've done 2 already. Right. One possibility, so what we did last week is relative to our X point down here, we pick our stress average on the what? Right-hand side, right? Today, what we have just done is we pick the stress average on the left-hand side, and all the three circles are within the operating bracket. So this is good. Okay. Now, the next one we are going to do, same thing. Okay, we already found one value already. So the next thing, before I do the next possible solution, did I teach you all the rules of the circle yet? Yes or no? No? Yes? Did I make you draw a circle and pick a point yet? No? Okay. So those of you that have a compass, I want you to do this, either at home or over here. We are going to learn the rules of the circle. Okay? So what do we mean by the rules of the circle? Basically, we are going to construct a circle. We're going to draw a circle. Okay? This is my circle. And my circle has a center I call O. Okay? As a center I call O. I'm going to draw a line in any orientation. I'm going to draw a line in any orientation. But it has to go through the center of the circle, 0. It has to go through it. I'm going to label this point A. I'm going to label this point B. Okay. Then from here, I'm going to pick an arbitrary point. Okay. I'm going to pick a point somewhere around here. I'm going to call it my point X. Okay. You can pick anywhere. Okay. You want, you can pick a point over here. You can pick a point down here, and we call it point Y. You decide. Okay. Point X and point Y are arbitrary position. Next, I'm going to join point A. Okay, we are going to join point A to point X and point X to B. Okay. And what you realize is this angle is always 90 degrees. Okay. The angle is always 90 degrees. Okay. If I do again for point Y, let's say point Y, I put somewhere. Okay, okay, point Y I pick somewhere down here. Over here, you can see that this is always 90 degrees. Always. Okay. So now I'm going to choose, I'm going to take from point Z, point X, I'm going to connect to O. Okay, here's my O. And I'm going to call this angle alpha. If that angle is alpha, this angle over here is also alpha because both of them have the same radius. Because point O is the center of circle. Okay. So when that's the case, this angle over here will be equal to 180 minus 2 alpha. This angle over here will be equal to 2 alpha. So I'm going to take my protractor to measure that angle over there for me. Alpha is 25 degrees. 25 degrees. If I measure my 2 alpha, it is spot on 50 degrees. Okay. Okay. So this is what we mean by the rules of the circle. Okay. So we are going to employ the rules of the circle to find the other possible